students preparing for NSEP. I'm sure you're full excited and full josh and preparing for your NSEP exam and other Olympiads and your board exams, JEE, NEET. And while you do that, the concepts matter. So welcome back to the series of Noodle Chopstick. And what is this series about? We have spoken about it earlier as well. So when you face a situation, maybe in real life or in academics, wherever, there are two ways to handle that situation. Either you go a little noodle way or you go straight line chopstick way. So noodle chopstick, right? So obviously noodle way is all complicated, messed up, a lot of errors will happen, lengthy, time consuming. And chopstick method is straightforward. There is no complexity. It is easy to understand, easy to explain, and less time consuming. So obviously the noodle method is very, very lengthy. It is confusing, error prone, and difficult to grasp. But surprisingly, many teachers still use the noodle method. And I always think there might be two reasons for that. One reason might be when those teachers were students themselves, they learned it that way and they never explored beyond whatever they learned. So they thought this is the only way to solve that situation. And they keep passing on the same information, which is very complicated. Or maybe they know the alternate solutions, but they don't want to reveal it to you because maybe, I don't know, I'm just guessing, they want to portray this topic or a concept as a rocket science. And you might think, okay, wow, what a big concept. And had I not come to this teacher, I would have never been able to understand it. Okay, whatever the reasons, I am going to stick to the chopstick method because that is the way to go. My name is Bhavdeep Sethi, and I have been teaching physics for a long time. And I have a big passion for physics, and I have equal big passion for teaching. And with those two passions, I ensure that every student out there converts into a physics lover. I always say physics ko ratta maroge to physics bura maan jayegi, and there is a lot to learn in the nature. Go out in the nature, explore nature. That is the best textbook out there. So in today's series, we are going to talk about toppling. Now, toppling, honestly, it's such an easy concept that you can understand it in 5 to 10 minutes. But again, surprisingly, I come across students who say, "Sir, confusion बहुत है." क्योंकि they memorize different formulae for different situations and then they get confused. It is length by two or width by two. And those are the things I'm trying to minimize out here. So we'll go with the chopstick method and understand toppling in less than maybe 5 to 10 minutes. So let's start. So let's actually start with a situation here. Situation as in we'll take some box here. Let's say there's a box here, a very beautiful box out there. So let's say the box is on the floor. So we draw the floor. So this is the surface. And let's assume the surface is very rough. When I say very rough, okay, it doesn't look like a rectangle, but that's okay. That's okay. The purpose is to learn the concepts and not, this is not an art class. And even if it is an art class, what a beautiful piece of art. But anyways, now let's say the thing is the surface is so rough that my force that I'm applying, it's not going to move it. It's not going to start to slide. Taking some assumptions here, let's say this is 4 meters, let's say. Okay, sorry. So let's say this is 4 meters here. This dimension is 4 meters and this dimension is 8 meters. Just for the sake of understanding. And let us say this box is 20 kilograms of mass. If this is 20 kilograms of mass, first of all, you have to understand that mass is spread out. And again, it's a three-dimensional thingy. So box, 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 oh, box. Okay. So it's a three-dimensional thingy. So this is 8 meters by 4 meters, and then depth. Depth doesn't come into play here. That's all uniform. But my point was the mass is spread out. So there's a molecule out here. It's being pulled by gravity. There's a molecule out there pulled by gravity. Molecule pulled by gravity. So all that gravitational force is spread out. First of all, you have to understand that. Right? But with the concept of center of mass, we can say we can simplify that situation and say the entire force. So 20 kilograms is basically 200 newtons, right? 200 newtons. So we can say that 200 newtons is actually applied at the center of mass here. So 200 newtons. Now again, you really have to understand because you are NSEP students. This is a conceptual thing, that this is just an assumption here, right? So that it doesn't mean that 200 newtons is applied there. It is spread out all over, but we can simplify. We are modeling it as a point mass here. Now, similarly, now if it's on the floor, excuse me, let's say it is sitting on the floor, then it is not accelerating up or accelerating down. So that means there is a net acceleration of zero. And that means the net force has to be zero. So where is that other force coming from? So when the box pushes the floor pushes it up by Newton's action reaction third law of motion. And again, that's all spread out here. It's all spread out here like this. But again, with the concept that we studied, with the modeling of the things around center of mass, we can say all those forces, they add up to 200 newtons, and because they are all symmetrical, the entire thing can be visualized. It's not a fact. Again, I'm repeating that it's not a fact. It's just a visualization here, a modeling here, that I can say entire thing is applied here as the 200 newtons. Right? Things are in equilibrium. There's no movement, no acceleration. Looks good. Now let's say I come here and apply a force. So it was sitting here and I apply a force of 200 newtons. Let's make it 50 newtons to start with. So let's say this is 50 newtons. Now since the box is not moving, that clearly means there's another force pushing it back, and that's obviously no brainer. It's a friction force, and it has to be equal and opposite. Now here we are assuming that the friction is big enough, as in mu times the normal force is much more than that. So yeah, so 50-50. Now in the first look, things look very cool here. Vertical direction, x-axis 200 minus 200, no force, no acceleration. Horizontal direction 50 positive, 50 negative, no net force in the along the x-axis, so no acceleration. Looks cool. But wait a second, something doesn't add up here. So along y-axis no net force, along x-axis no net force, but what about torque? There is a torque. See, when these forces were not applied, these two were along the same line. So you take any point, let's say you find the torque here, zero torque, nothing. But let's say you find about this. So 200 times 2 meters clockwise, anti-clockwise, and 200 times 2 clockwise, they cancel. And for the sake of understanding, you can take any arbitrary point in 3 dimensions maybe, and these two will contribute to no torque because they will cancel out each other, but not these because they're not along the same lines. Let's take an example point as this point. So if I were to take the torques about this point, this contributes nothing, this contributes nothing, but wait, this contributes a clockwise torque and this also contributes a clockwise torque. So there is a clockwise torque, and how much is it? 50 times this distance. Now if the total was 8, this is 50 times how much? 50 times uh, I think I'll change the numbers here so that it's easy to understand to start with, because 50 would take it all the way there. So let's start with 25 to start with. So let's say this was 25 and 25. So let's say this was 25 newtons and 25 newtons. Just to start with, I'm going to increase it to 50, but for now 25, 25. Now, how much is the torque of this about this? So 25 times this distance. If the whole thing was 8, this thing is how much? This thing is 4. So 25 times 4 is 100 newtons. This is 100 newtons, right? This is contributing 100 newtons of clockwise. Same for this, 25 times this distance, which is 4. So 25 times 4 is 100. So 100 plus 100 gives me a total of 200 Newton meters of clockwise torque. And let me note it down. So what I have right now is 200 Newton meters of clockwise. By the way, clockwise is taken as negative. You can write negative. But for now, let's write it as clockwise. So 25 times 4 is 100. 25 times 4 is 100. Both of them clockwise. They add up to 200 Newton meters clockwise. But it's not rotating. You can see it's not toppling. Toppling would be, okay, it started to rotate. It topples, but it's not toppling. So what's going on? What's going on here is, think about it, visualize it, take some block and try this. If you're going to apply a force here, isn't this side pulled a little up? It has a tendency to go up. So it's not pressing as much on the floor. But on the other side, the right side here is pressing more. So what will now happen is, all those forces that we look, they were equal. They're not equal. Those forces are not equal. What is actually happening is these forces reduce and these forces are more. So overall, the net effect is this 200 newtons will shift to the right, because think about this, these contribute less, these contribute more. So overall, the net effect is the normal force is going to shift towards the right. Now again, since you are an NSCP student, you should really understand these are the modeling things. It's not like 200 newtons is applicable at one point. No, it's not. That's not how it works. So, but the net effect of that can be modeled as we are saying 200 newtons will actually shift to the right. And how much will it shift? Let's try to understand. See, there is a 200 Newton meters of clockwise torque. This says I'm not going to let you topple. So let's understand what is the purpose of life. The purpose in the life of the friction force is jane nahi dunga, jane nahi dunga. It doesn't want you to slide. It prevents any sliding motion out there. Similarly, the purpose of the normal force is topple nahi hone dunga, topple nahi hone dunga. Just remember it that way. So it says, I'm not going to let you topple this block. I'll do whatever it takes. Like it says, I'm not going to let you slide. It says, I'm not going to let you topple. I'll provide, since these two are providing clockwise torque, I'm providing anti-clockwise torque. How much? Exactly this much, so that it doesn't topple. Think about it. As soon as it shifts there is an anti-clockwise torque provided by that. And how much does it need? It needs 200 Newton meters. But this was 200 newtons. So what will it do? It will shift from here to here 1 meter. Now think about it. This was contributing 100 Newton meter clockwise, 100 Newton meter clockwise, total of 200 Newton meter clockwise. It says I'm going to provide 200 Newton meter of anti-clockwise. Now it is not going to topple. So what has happened, as soon as you provided 25 newtons of force, the normal force shifted to prevent toppling. Now let's say I increase this force. So let me increase it to the original value that I was thinking. Let's say 50 newtons. Friction says जाने नहीं दूंगा, जाने नहीं दूंगा, and it also adjusts itself to 50 newtons. This cannot increase because at the first thought it may be okay. Let's say this increases. It can't increase because it has to balance that no net force in the y direction, because if it increases then there is a net force upward. That obviously doesn't happen. So what happens is this remains 200 newtons and says, okay, 50 times 4 is 200 and 50 times 4 is 200. Total of 400 Newton meters of clockwise torque is being applied. This says I have to provide 400 Newton meters. He'll say, what if I make my distance as 2 meters? And that is exactly what it will do. But remember one thing, that the total width of this is 4 meters. So half of that is 2 meters. So now it is right at the edge. It is actually being applied here. So this is 200 newtons of force. Now think about this. This is 50 times 4 is 200. 50 times 4 is 200. Total of 400 Newton meters of clockwise. This says 200 times this distance of 2 meters. So 200 Newton meters. 200 times 2, 400 Newton meters of anti-clockwise. The box is still not toppling. But what happens if I increase this to, let's say, 51 newtons? This can't do anything. See, it can't go any further. It can't increase its magnitude because it has to remain exactly equal to this. And that is the point. That is the case when this will start to topple. So it starts to topple when this torque is greater than that torque. So let's see what will happen. So let's take it from more kind of variables kind of, so that you can understand it conceptually using the formulae and the equations that many of the teachers will make you memorize kind of, right? So let's say this was the floor, and let's take some variables here. Let's say the mass of this was not 20 kg, it was m. So I can say, okay, if this was m, then mg is acting downwards here. This doesn't change, gravity doesn't change its behavior. Now let's say I apply a force of F here, and let us say the width of this was W and the length of this was, or let's call this height. So this is height and this is width, right? Or let's call it length. I don't know. Well, this looks more like a length, and width would be the depth. Oh, the width looks good to me. So let's keep it width, right? So I know The corner case was, or the limiting case was when mg was acting here, and this was also the force of friction. Friction force would actually be equal and opposite. So how much is the torque of this? F times h by 2, F times h by 2. So F times h by 2, F times h by 2 becomes F times of h. So F times of h is the torque, the clockwise torque. How about the anti-clockwise? Anti-clockwise is mg. This doesn't do any torque. This doesn't provide any torque. So mg times this distance, which is width by 2. So the anti-clockwise is mg times width by 2. That's the anti-clockwise torque. Now, when will it start to topple? It will start to topple when this wins, right? This wins. So when F times H is greater than that, this is when it will start to topple. So how much force do I have to apply? I have to apply this much of force. And that is all. I mean, there are different cases you will come across, different fancy versions of the questions can be made, but it all comes down to the same behavior, that this is saying topple nahi hone dunga, and it'll take whatever it takes. It keeps shifting, 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 shifting. And at the limiting case point, it just reaches the corner and then it says, I'm done now. Kind of like how friction gives up after a certain point. This has to give up, it has a limitation. So you see how easy it was. If you always study the things in the chopstick manner, it's going to be very easy. Now, if you like this video, I would encourage you to subscribe to this channel, like this video, share this video with your friends, let them also get education in the way it has to be. I'm going to bring up more conceptual classes, but by the way, there is the Achievers course that I have started. So 24th of November is the NSEP exam. So I started this course on 4th of November, where we are having daily classes, daily 1.5 hours of classes, where we only do PYQs, and we do PYQs from NSEP, Indian Physics Olympiads, and also other international Olympiads. And the course is very cheap. It is priced at 2222. But by the way, you can apply this coupon code BS Pro 1 and get it for 2000 rupees only. There's going to be assignments after each class, and Sundays will be your, and also one thing, if you are looking for a longer term course, that longer term course is called Physics Mastery 2025, that was started few months back, and we have already completed 2 modules. There were 5 modules, so every module was 2500 rupees, times 5 is 12,500. But what you can do now is we are starting module 3, and that module 3 is going to be, so you will be getting 3, 4th and 5th, right? So 3 modules times 2500, you get it for only 7500 rupees, and then you get the recordings of these two. So again, I'll repeat that. So if you pay for module 3, 4 and 5 now, you pay only 7500 rupees minus 10% discount. That coupon applies here. So you're paying 7500 minus 750. That's 6750. So 6750 rupees. You get the 3 modules live and the recordings of the first 2 modules. And the module wise is breakup is given here. We have spoken earlier as well. Now, any prerequisites, obviously there are prerequisites to join this course. The first thing is willingness to learn, commitment to hard work, and josh. And I always say trigonometry nahi aata main sikha dunga, vector nahi aata main sikha dunga. All you need is willingness, determination, josh, energy. That's all that is needed. And there are lot many students than you can even imagine who have got the medals. I mean, unfortunately these news do not appear in the newspaper, so people are not aware that India has been winning the gold medals, silver medals, and bronze medals on the international stage. So I would like to see you getting medals like these one day. And thank you so much. Subscribe to this channel for more updates. So thank you. Keep up the high Josh. See you soon.